Hi, we're going to move on to our next topic, which happens to be profit and loss and discount. Now, before we move on to the concepts of this particular topic, let's look at an example, a real life application. I went to a shopping mall to buy a dress for someone, and when I looked at this particular dress which I liked in a particular shop, I looked at the price tag and I also observed that on the price tag a discount was mentioned which was of 30%. Now, it's a normal habit, I think, for all of us to look around and see if there is something similar available at a better price. And hence, when I went to a nearby shop, I saw a similar dress, but the discount now mentioned on this dress in the second shop was 20%. I started discussing this with the shopkeeper, and on further negotiation, the shopkeeper was willing to offer an additional discount of 10%. The dilemma for me now was whether I should buy this dress from the first shop or the second shop. Which one would be more effective in terms of cost? Obviously, lower cost. Let's try and look at this example a little later after we've gone through some concepts of profit and loss and discount, and then hopefully we'll be in a better position to make up our mind. So we'll now move on to some concepts. We'll now start off with some basic concepts on this topic, profit and loss, discount. Now, what do we really mean by a profit? In very simple terms, profit would mean if I have purchased an article at a certain price, let's say CP, which is the cost price, and if I sell that article at a price which is SP, selling price, and if I am selling at a price which is more than the price at which I have purchased, then I'm going to make some money, which is nothing but profit. And hence, in terms of a formula, profit would be nothing but selling price minus cost price. On the other hand, if I have purchased an article at a price CP and I am selling it at a price SP, where I am forced to sell it at a price lower than the price at which I have purchased, then I lose money. Hence, the formula for loss would be cost price minus the selling price. Now, this formula for profit or for loss will give me the value in rupee terms. But there are times when I need to calculate the profit or the loss in percentage terms. So if I want to calculate this in percentage terms, profit percent would be the numerical rupee value of profit divided by the cost price multiplied by 100. Very important point that we need to remember, profit percent would always be calculated on the cost price. And similarly, loss percent would also always be calculated on the cost price, and hence the formula for loss percent would be loss divided by the cost price into 100. Now, through these two formulae, what we're doing is we're converting the profit or loss, which was in rupee terms, into a percentage of the cost price. There could be other problems where maybe the cost price is given and the profit or loss percent is given, and we need to arrive at the selling price. And hence, if we have to understand selling price in terms of cost price, then how would we do it? Now, this is where we would go back to our concepts that we had learned in percentages, where we learned how to increase a number by a certain percentage or decrease a number by a certain percentage. When I look at selling price, in a profit scenario, it would mean that the cost price is increased by a percentage which is P% if P represents the profit percent. On the other hand, in a loss scenario, selling price would be L%, where L represents the loss percent, L% lower than the cost price. And hence, if we have to write formula for selling price in a profit scenario or a loss scenario, then it would mean 100 plus P% upon 100 multiplied by the cost price. So if we take a simple example, suppose we say that the profit percent is 20%, then it simply means that the selling price would be 20% more than the cost price, and hence if I use this kind of a formula, it would mean that selling price would be 120% of the cost price. On the other hand, if the situation is a loss situation, then the selling price would be 100 minus the loss percent upon 100 multiplied by the cost price. So instead of a 20% profit, suppose I make a 20% loss, then my selling price would be 100 minus 20, which happens to be 80% of the cost price. Now this is in terms of a formula. But what we can also do is convert the profit percent or a loss percent in terms of a fraction. So if I say that the profit percent is 20%, then 20% as a fraction would be 1 by 5, and hence I would say that my selling price should be 1/5 more than the cost price, which would mean that selling price should be 6 by 5 of the cost price. Now it's good to know both the methods, because there are certain percentage values where this kind of a representation would be useful, whereas there are certain other percentage values. To give you some example, if we say that the loss is 14.28%, it is extremely important to know reciprocal values, and hence if we know that 14.28% would actually mean 1 by 7. So that kind of a value would be very simply solved, or the problem using that value can be simply solved using this fractional equivalent method. So 14.28% is 1 by 7. If that's the loss, then my selling price should be 1 by 7 less than the cost price, and hence I can straight away write that as selling price is 6 by 7 of the cost price. So these are some basic formulae for profit loss, or expressed in percentage terms, or how we can actually write down selling price in terms of the cost price under a profit situation or a loss situation. We're now going to look at our next concept, which is buying and selling of multiple articles. Now let's look at the first type in this. We are looking at a specific case where items are sold at the same selling price. So suppose I make a statement, if two items are sold at the same selling price, one is at a profit of P% and the other is at a loss of P%. What we need to note here, the selling price for both the articles is the same. The profit percent and the loss percent in numerical terms is also the same, which we've referred to as P%. So hence, what would be the effective loss or profit? Now, the answer to this question, whenever we've asked this question in a class, we've got all possible answers. But the correct answer here would be that effectively there would be a loss. So hence, if I rephrase that whole question or go through the whole question again, if two articles are sold at the same selling price, one at a profit of P% and the other at a loss of P%, then there will be a net loss, which is going to be P square upon 100%. Now this loss that we've stated is in terms of percentage. So if I tell you that two articles are sold at the same selling price, one at a profit of 10% and the other at a loss of 10%, then the overall loss in that case would be 10 square, which is 100 upon 100, so 1%. Please note that the profit percent and the loss percent has to be the same if you want to apply this particular formula. This loss is expressed in percentage terms, but if I want to find out the rupee equivalent or the rupee value of the loss, then the absolute loss in this case would be given by this formula, which is 2 into P squared into the selling price, which is the same, upon 100 square minus P square. Now in a problem, if the value of P, which is in percentage terms, is given, and if the selling price is given, then using this formula we can actually find the loss in rupee terms. So whenever two articles are sold at the same selling price, one at a profit of P% and the other at a loss of P%, in such a situation you would always make a loss, and we've already looked at the formula for loss in percentage terms and also in rupee terms. We've just seen an example when two articles are sold at the same selling price. What if two articles are purchased at the same cost price and then sold, one at a profit of P% and the other at a loss of P%. Now this example might seem similar like the previous one, or to the previous one, where the profit percent and the loss percent happens to be the same, but the change is that earlier two articles were being sold at the same selling price. Now we are talking about a case where the cost price of the articles is the same. And if the cost price is the same, and we know that profit percent and loss percent is always calculated on the cost price, then whatever is the profit made on one article will be equal to the loss made on the other article, and hence in such an example there would be no profit, no loss, and hence this is a situation where there is no profit, no loss, and hence there is no question of being expressed either in percentage terms or rupee terms. So when two articles are purchased at the same cost price, and then one is sold at a profit of P% and the other is sold at a loss of P%, it's a situation of no profit, no loss. In this topic of buying and selling of multiple articles, let's look at another kind of an example. Suppose we say cost price of 10 articles is equal to selling price of 8 articles, and hence the question asked would be, how much is the profit or loss percent? Now let's try and look at this problem conceptually. I am buying 10 articles, and whatever is the cost that I have incurred, I have actually recovered that cost by selling only 8 articles. So obviously it should mean that I have made a profit. The question is, how much is the profit percent? So let's try and understand a detailed way of solving the question, and we look at this detailed way, which is a foolproof method. Whatever be the type of question, it can be used, and then we would also look at a shortcut. So suppose we start by saying cost price of one article is 1 rupee. The question says cost price of 10 articles, and hence cost price of 10 articles would be 10 rupees. Now the problem has told us that cost price of 10 articles is equal to selling price of 8 articles, and hence we can say selling price of 8 is also 10 rupees. Now if I want to calculate the profit percent, formula for profit is selling price minus cost price, but I cannot use selling price of a certain quantity and cost price of some other quantity. So if I want to calculate the profit, I need to find the cost price of 8 articles, and if I follow this logic, then cost price of 8 articles would be 8 rupees. Now when I compare these two, I can actually notice that the profit happens to be 2 rupees, 10 minus 8, so 2 rupees. And if I want to find the percentage profit, where the formula is profit, which is 2, upon cost price, which is 8, multiplied by 100. And hence the percentage profit in this case is 25%. So where the problem given was cost price of 10 articles is equal to selling price of 8 articles, then the profit percentage is 25%. Let's try and solve the same question using a shortcut. We've been told that cost price of 10 is equal to selling price of 8, and we've also discussed conceptually that the cost of 10 has been recovered by selling 8, and hence this tells me that I have saved 2 articles. So now I can look at the percentage profit in terms of the number of articles saved. So I am saving 2 articles on selling 8 articles, and hence the percentage profit can be written down as number of articles saved or gained divided by number of articles sold multiplied by 100. So in this type where cost price of 10 is equal to selling price of 8, the shortcut would be number of articles gained divided by number of articles sold multiplied by 100, which would give me the same value, in this case 25%. Now let's reverse the situation. Suppose I say cost price of 8 articles is equal to selling price of 10 articles. Conceptually, the cost that I have incurred to purchase 8 is recovered only when I sell 10. So automatically I know this is a loss situation. If I use the same shortcut, where we had said number of articles gained, which would now be number of articles lost, divided by number of articles sold into 100. Now in this case, if the cost price of 8 is equal to selling price of 10, I am losing 2 articles on selling 10 articles, and hence my percentage loss in this second example would be 2 upon 10 into 100, which would be 20%. So whenever we look at an example where cost price of M articles is equal to selling price of N articles, what we need to look at is whether the situation is of number of articles gained or lost, that value divided by the number of articles sold into 100, and that would give us either the profit percent or the loss percent. In this topic of profit and loss and discount, there are certain specific types of problems. So let's look at a couple of them. Let's first look at a specific type which is on successive discounts. Now it's very common practice nowadays that when you go to a shop to buy something, you are offered a certain discount, and if you negotiate further, then there is a further discount that gets added. Now what we need to understand here is that the further discount is not on the original price, but it is on the reduced price, and hence this is what is known as an example of successive discounts. Now this is identical to what we've learnt in percentages as a concept called as successive percentage changes, and we are actually going to use the same formula. So if we say that a shopkeeper offers a discount of A% followed by another discount of B%, then we go back to our formula of successive percentage changes, which was A plus B plus AB upon 100. The only difference being, since it's a discount, we're going to subtract it or use a negative value, and hence we say if the first discount was of A%, so minus A, further discount of B%, so minus B, plus AB upon 100, and this entire thing as a percentage would be the effective discount that the shopkeeper has offered me. Now if I have to take some example, suppose we say that the shopkeeper offers a discount of 10% followed by another discount of 5%, then my calculation would be minus 10 minus 5 plus 50 upon 100, which happens to be 0.5, and hence this would mean minus 14.5%. The negative sign simply indicates that it's a discount, and hence the effective discount that has been offered to me by the shopkeeper is 14.5%. This is one specific type of a problem, which is successive discounts. Another type of problem in this topic is what is titled as freebies. Buy 3 get 1 free. I mean, how many times have we heard such a statement? Now whenever we say buy 3 get 1 free, and if the question asked is, so what is the discount that the shopkeeper is really offering you? How do we solve this? If I am going to buy 3, that means I am paying the price for 3 and I am going to get 1 free. So effectively, I am going to take away 4 articles from that shop. Now out of these 4 articles, I have got 1 free. And hence if I want to find the percentage discount in this case of freebies, the percentage discount would be number of free articles, which in this case is 1, divided by the total number taken away, which in this example was 4. And hence if I say, and obviously this needs to be multiplied by 100 to convert it into percentage. So the example that we've looked at, buy 3 get 1 free, would mean 1 free on 4 taken away, and hence the discount would be 25%. So these are two very, very common applications of this topic of profit and loss and discount. The first one was on successive discounts and the second one was on freebies. Let's look at a few more applications, and the application that we are considering now involves cheating. Okay, within cheating we will first look at an example where there is adulteration involved. So one of our favorite examples actually, a milkman who has 4 liters of milk. he adds 1 liter of water to these 4 liters of milk, and he tells his customers that I am actually selling the milk that I have at cost price. So actually, is he selling it at cost price and hence not making any profit, or is there a profit involved? So suppose the question is, a milkman adds 1 liter of water to 4 liters of milk, claims to sell it at cost price. So how much is the profit or loss percent? Let's look at how to solve this question. Suppose we say that the cost price of 1 liter of milk for the milkman is 1 rupee. Now the milkman had 4 liters of milk, and hence we would say that the cost price of 4 liters would be 4 rupees. The milkman is adding 1 liter of water, and hence the milkman is now going to have 5 liters of solution, but there is no change in the cost because there is no cost associated with water, and hence we say that the cost price of 5 liters is still 4 rupees. Now the milkman claims to sell the milk that he has at cost price, and hence we say selling price of 1 liter is 1 rupee. The milkman is now going to sell 5 liters in all, and hence the selling price of 5 liters would actually become 5 rupees. If we compare these two, we can obviously see that there is a profit involved, and hence if we find percentage profit using our formula, it would be profit, which is 1 rupee, divided by the cost price, which is 4 rupees, into 100, which is 25%. So though the milkman claims to sell at cost price, because he has added water to milk, he is actually making a profit. If we now change one parameter in the question, suppose we say a milkman mixes 1 liter of water with 4 liters of milk and claims to sell at a loss of 20%, or he claims to offer a discount of 20%. How would the situation change now? Cost price, nothing would change, but selling price is no longer 1 rupee. Selling price is at a discount of 20%, and hence this would become 80 paise. And the selling price of 5 liters now is no longer 5 rupees. The selling price would now be 4 rupees. And now if we compare these two, we observe that it's a no profit, no loss situation. So though the milkman claims to sell at a loss of 20%, actually because the milkman has added water, there is actually no profit, no loss. So this is one example of cheating which involves adulteration. A second type of cheating could be an example of using faulty weights. So suppose we say that a shopkeeper claims to sell his articles or whatever he is selling at cost price, but instead of using a 1 kilogram weight, the shopkeeper uses a 900 grams weight. So obviously the shopkeeper claims to sell 1 kg, but the customer is only going to walk away with 900 grams, and hence even though the shopkeeper claims to sell at cost price, the shopkeeper is actually going to make a profit. How do we solve this question if we want to find the profit percent? Now this example would actually be similar to what we've seen earlier, where we say cost price of 1000 grams is equal to selling price of 900 grams. Why are we saying that? Shopkeeper is going to recover his cost of 1 kg by actually only selling 900 grams. And if we go back to our shortcut that we had learned, the shopkeeper is going to gain 100 grams on selling 900 grams, and hence if we look at the profit percent, it's going to be 11.11%. So this is similar to cost price of 10 articles is equal to selling price of 9 articles. Here specifically it was cost price of 1000 grams is equal to selling price of 900 grams. So when a shopkeeper uses faulty weights and sells lesser than what he's claiming to sell, he's going to make a profit. And how do we calculate the profit percent? Again, whatever is the quantity gained divided by the quantity sold multiplied by 100. A slight variation of this example of faulty weights could be if the shopkeeper is using a spring balance. And if the shopkeeper is using a spring balance, it will actually not be a case of cheating, because the situation is going to be exactly opposite of what we saw. So let's look at this example. A shopkeeper claims to sell at cost price, but when the shopkeeper uses a spring balance, the spring balance shows 900 grams, where actually what the shopkeeper is giving out is 1000 grams. So now the faulty weight that is being displayed is actually a loss for the shopkeeper. So now if we say that the shopkeeper claims to sell at cost price, he's going to make a loss. Why is that? When the spring balance shows 900 grams, the customer is actually going to pay only for 900 grams, but is going to walk away with 1000 grams, which is a kg. So when the spring balance shows 900 grams instead of a kg, the loss for the shopkeeper, and in this case if you want to find the percentage loss, it would be quantity lost, which is 100 grams, divided by quantity which the customer goes away with, which is 1000 grams, multiplied by 100, and this would be a 10% loss for the shopkeeper. So this is how a faulty spring balance can actually result in a loss for the shopkeeper if the shopkeeper actually had started off by claiming to sell at the cost price. If this spring balance example is applied to, let's say, a raddiwala, then this is no longer a loss for the raddiwala. This is actually a profit for the raddiwala, because the raddiwala is actually going to pay the customer for whatever the spring balance shows. So this is a very interesting case where the same faulty spring balance, if used by a shopkeeper to sell something for which the shopkeeper is going to get money, it will mean a loss. But if this spring balance is used by a raddiwala, where the raddiwala will have to pay the customer, it will actually mean a profit for the raddiwala. So let's go back to the example that we started off with. I've gone to a shopping mall to buy a dress for someone. I go to a first shop where the discount offered to me was 30%. So the first shop discount is 30%. And then I move to a second shop where the discount listed was 20%, but when I negotiated further, I was offered a further discount of 10%. Now, if you've understood the concepts, then we should know this is a case of successive discounts, and hence, effectively, what is the discount being offered? It is minus 20, minus 10, plus 200 upon 100, which would be plus 2, and hence this translates to an overall discount of 28%. So in the given situation, obviously what this means is that buying the dress from the first shop would be better for me because I will save more money or spend lesser money. Suppose I now need to calculate what should be the value of this second discount offered so that the effective discount becomes the same in both the cases. So then I would solve it as minus 20 minus x, because that is now the unknown for me, plus 20 multiplied by x divided by 100. This is how I would use my formula for successive discounts, and what I want this to turn out to effectively is a 30% discount, and hence I would write it as minus 30. If I solve this, I will get x as 12.5%. What this tells me is that if the second shopkeeper had offered me a further discount of 12.5%, then the effective discount would have been the same in both the cases, and hence if I can bargain with the second shopkeeper for a further discount of more than 12.5%, then I would have got a better deal from the second shopkeeper. Now if we know these concepts and the formula of successive discounts, the next time we go shopping, we obviously can get a better deal out of shopkeepers.